What is going on, everyone? This is Ahmad Awais, and today I'm going to be talking about the new JavaScript runtime called Dino. Everyone is talking about it, and people are confused if it's called Deno or Dino. But I have this on kind of good authority from the creator himself that they have agreed that it is called Dino, like from the dinosaur. As you can see, the logo has a dinosaur, and there is rain on top of him or whatnot. But let's explore what this Dino, JavaScript runtimes looks like. So first of all, I have actually wrote a blog post on this thing, and I'm going to be teaching you. We are going to be building a couple of apps with Dino to actually learn Dino with example. In this video, I'm going to be talking about what is Dino, how it is different from Node.js, and we are going to be building 3 different applications with Dino. Very simple one, nothing too complex, just a basic introduction so you kind of get the idea behind this, new JavaScript runtime. So first of all, let's go to dino.land. That is the actual, official site for Dino. And as you can see, Dino is a secure runtime for JavaScript and TypeScript. If we go to Node.js, as you can see, Node.js is also a JavaScript runtime built on Chrome V8 JavaScript engine. And the case with Dino is quite similar. It is also built on V8 Chrome engine, but the difference is Node.js was built 10 years ago with JavaScript and C++, whereas Dino is built with TypeScript and Rust. So there's a huge difference here. It is built with Rust and TypeScript, and the TypeScript support is built in. So one of the focus in the Dino community, or the idea behind Dino, is that it is secure by default. So what happens is Dino is actually like your web browser, and it is like a command line interface for your web browser that you can run inside your terminal or a server. But it is secure by default. It is not like Node. Like in Node, every file can, any file or any CLI can do basically anything. Whereas in Dino, you have to actually tell or allow specific permissions for this sandbox so it can access things out of that sandbox. Everything in Dino actually runs inside of a sandbox, and that sandbox has no access to anything except itself until you specify it. For example, there's no file or network or environment access unless explicitly enabled. And it supports TypeScript out of the box. Like, you don't even have to write any TypeScript configuration file. But if you want to customize it, for example, I think Dino comes with strict, checking enable. If you want to customize it, you can definitely do that. But you can just go ahead and start writing TypeScript without having to, write any configuration file or whatnot. And Dino basically ships as a single executable file. I know that this feels a bit odd, but that is a new concept here. And similar to many awesome, new languages like Golang, it is, I feel like it is similar to Golang in a couple of features. Like it has a, dependency inspector where you can use Dino info to check the dependencies. And then it has a code formatter, just like Golang has. You don't really need any code formatters like Prettier or anything. It has a built-in code formatter, Dino FMT. And again, similar to Golang and other native programming languages, Dino actually comes with a standard library that has a couple of really good functions in it. So you don't have to rely on any third party, but you can if you want to. When I was writing this article, I ended up researching a little bit more fun stuff. For example, Dino is basically an anagram for Node. For example, here is Node. Let me just zoom it a little. So here's Node. If you take DE from Node and put it behind, it becomes Dino. And there's a fun joke going around like Node dot split. If we split every part of Node and convert this string into an array and then sort it and then join all of it, it actually becomes Dino. So if you sort the Node string, it becomes Dino. The core of Dino is what you'd need to write modern JavaScript, TypeScript, and WebAssembly code. It kind of core actually has a JavaScript bundler, a debugger, a test runner, a code formatter, and a documents generator, as well as the dependency inspector and other things like WebAssembly support. I already talked about it is secure by default and it comes as a single executable. So how about we go ahead and start installing it? There are a couple of ways you can install it, with shell or with homebrew, or you can just, kind of take a look at this guide called Dino install. And here you'll find a couple of ways, using PowerShell or Scoop or Chocolatey, whatever is the choice of your OS. I suppose it is covered here. So for me, I just use Homebrew because I'm on a Mac. I just used brew install Dino and it ran and it installed Dino for me. I had nothing to do beyond that, And then to verify, you can either type Dino hyphen capital V or hyphen hyphen version and see if Dino is actually installed in your system now. Like I have a Dino 1.0 installed. And it also gives out information about what version of V8 and TypeScript it is using, which is like quite handy. You can also install Dino completions. Dino CLI actually has the power to generate these completions. For example, if we go to Dino --help, as you can see, there are links to docs, modules, and to start a REPL, REPL is a read evaluate print loop. You can just type Dino and press enter, and you'll be in that REPL. And then to run a script, you need to use Dino run and then link or a path to a file or actually a URL. It actually runs a URL, a module from a URL as well. Or you can just evaluate or whatnot. And there are a bunch of other options. Like for example, it has its own bundler. You can bundle that module into a single file. If you are creating a program, you can kind of bundle it with its dependencies into a single ES module. It can cache your dependencies. It can generate your shell completions just like that. For example, to generate shell completions for batch, you can type Dino completions batch and put it here and kind of source it from there. If you go to the manual and then set up your environment, you'll probably get all of this information from here, using the allow environment flag and the shell auto completions and whatnot. You can generate documentation for your module. You can evaluate a script. You can definitely format your source files, generate help for, the one help we are here or for a particular subcommand. You can show the info about cache and related source files. Install a script as an executable. This is how you kind of create CLIs. You kind of create a CLI and install it as a script. And then there's read, evaluate, print loop. You can run a program, a file name, or a URL of the module. Both of these work. This is something completely new. You can run tests, print, runtime TypeScript declarations, and just use Dino upgrade to upgrade Dino executable to a given version, or just write Dino upgrade and it will upgrade itself to the latest one. And there are a couple of environment variables that are kind of available here. If you go to the manual and then set up your environment, for editors and IDE, it recommends a couple of community, extensions. For example, I use VS Code in the extension by this person, XZTroy, Xtroy, I don't know, is kind of recommended here. And you can use it to get all of the features right there inside your VS Code. For example, it will auto format and everything. Let's go ahead and install this in our VS Code setup. Open Visual Studio Code, click install, and there you go. A couple of more settings that I would ask you to do is go to this gear icon, open the command palette, search for Workspace Settings. I'm going to be using this Workspace Settings JSON file and put all of this information here. I actually got it from the README file of this VS Code extension. So what it is doing is we are enabling Dino for this particular project because it kind of, I think, conflicts with Node.js. So you have to enable it workspace by workspace. So I'm enabling Dino for this particular project, the project I'm in right now, the folder. And then for TypeScript and TypeScript React, I'm adding this particular setting. What it is doing is, let me just close the sidebar. What it is doing is it is actually defining the default formatter to be that extension. So when you press save, it kind of runs that Dino fmt command to format your code. And I'm going to explore all of that right now. So let's go ahead and try something. For example, for Dino run command, I'm going to ask for help. And there are a couple of things you can do here. For example, what this command does is it runs a program with a given file name or the path name to that file name, or the URL. For example, with URL, we can run this particular command and we can grant all the permissions by typing -a, or we can just grant the permissions to read and use the network by using these two flags. Remember that right now you have to define these flags right after run, not after this command. It wouldn't just work that way. So there are a couple of options. We can allow all the permissions or specific permissions, like allowing the environment variables, and other things like allowing the internet to work for your program and whatnot. We have installed the Dino core. We have set up our VS Code extension. Now I think we are ready to start exploring some Dino code examples. Here's an official example. If you run this, it prints welcome to Dino. Pretty easy and pretty great. How about we code this thing? So I'm just going to copy welcome Dino, and let's create a welcome.ts file. It is going to be a TypeScript file. And I'm going to log a string. See, log a string. And as you can see, I'm using single quotes here. Let me just zoom in a little bit. Single quotes here, whereas Dino actually used double quotes by default. So as soon as I press save, it is going to auto format my file and format it in the way Dino likes it. So there you have it. I've created this welcome.ts file, and now I'm going to just go ahead and run this. Okay, so we are going to type Dino run in the welcome.ts file. First, as you can see, Dino compiled this particular file and then it executed it, and we got this console log. If I run it again, it should not compile this again. It should just use the cached compilation from the last time. And that is exactly what happens. I ran it again and it is cached now, and it is using the cached version of that compilation again. So that is pretty simple, but how about we step up our game and kind of build something a bit more, let me say, app-like. So a cat command, Unix cat command, what it does is, for example, if I cat welcome.ts, it is going to just print everything that is inside this file. You see, so if the cat command takes an argument, that argument is actually the file name, and it prints out all the output for that file. How about we go ahead and cook this thing up? So I'm going to be writing a cat ts. So the first thing I'm looking for is if I can introduce some, Dino arguments here. For example, if I run Dino run cat.ts and then give it an argument of welcome.ts, how do I really access it? From the documentation, I was able to pick up that you have to write dino.args. So dino.arguments. Let's console log to see what happens there. So it just went ahead and compiled it. In the Dino args is actually an array. And inside an array, there are strings, which are the names of all the arguments. For example, if I give it another argument, which is the cat.ts file itself, it will have two strings, welcome.ts and cat.ts. So that makes our job easy. How about we start doing something with it? I'm going to write a regular for loop here. For loop where there will be let I is equal to 0. So we will start the iterator from 0. And I will be less than dino.args.length. And just iterate over this particular thing. For example, what we are doing is we are taking in the array length, which is going to be whatever the number of arguments you send to this program, and this for loop is going to iterate over that number of arguments only that number of time. For example, if there are 2 arguments, this loop is going to run twice. So now we know that there's a file name as a string. This is actually the file name. And now I'm going to define a file. I'm going to await and use a function called deno.open that particular file name. So here I'm using deno.open to open this particular file, and I'm kind of saving it as a reference in the file variable. Did you notice I'm using await and there is like no async function here? This is because Deno is capable of using await as a top-level await API. You don't really have to define an async function to use await in Deno, which is excellent. It is like a new top-level API in the modern JavaScript, and Deno is making use of it. So now that we have our file, what we need to do is we need to copy this file to our standard output, just like a cat does. So I'm going to await Deno copy, and the source will be the file, and the output will be on Deno standard out. See how this is all working, and I'm getting all the completions and suggestions here. This is because Deno is built with TypeScript, and this VS Code extension integrates it really well with our VS Code editor. So there you go. As you can see, the copy command is going to use the source and destination writer. It copies anything from source to destination, and our destination happens to be the standard output of our terminal wherever we are going to be running this. And finally, I'm going to close this file because I don't really need it. So what's happening here is we are looping over all of our arguments. For each argument, we define the file name. We open that file name here, call it file, and then we use this as a source to output all of the contents of this file, and then go ahead and close the stream. So how about we go ahead and run Deno run cat.ts, which is actually this particular file, and I'm sending it the argument of welcome.ts. Looks like we have an error. So what happened is it compiled successfully, but there is an uncaught permission denied. So the read access to welcome.ts is denied because it is asking us to actually explicitly define the allowed read flag so it can read this particular file. And I'm going to just go ahead and do that. This is actually where Node.js and Deno are different. Deno is sort of secure by default, and you have to actually allow its particular sandbox to a certain set of conditions that it can use going forward. So what we are going to do is we are going to define. So I'm going to write allow read access right after the run, and there you go. It's actually able to now kind of print in the entire contents of this welcome.ts file. And for example, if I were to give it cat.ts as well, it will go ahead, print the welcome.ts contents and then the contents of cat.ts. So that is working really good. Now let's move on to our third example, which is actually setting up our Deno, a basic Deno server. And I'm not going to be kind of writing everything from scratch here. I'm using the default, official example. How about we go ahead and create a server.ts file, and I'm going to paste the official example here. So what's happening here is I'm importing the serve function from this particular URL. So you can actually import things from URLs because there's like no package.json file or anything inside Deno. It has no support for npm or whatnot. You either define a file right here and use it, or use a URL for that particular module. And this module actually comes from the standard library, HTTP, where there's this file called server.ts that you can go ahead and explore on the Deno's website. We are importing the serve function from this particular server.ts module. And then I'm creating a new server at port 8000. I'm console logging that it is going to be running at localhost 8000. And for all of the requests that come to this server, I'm returning hello Dino as the body in the response. And I'm actually awaiting for it to complete. Again, here, this is the top level await API that is present in modern JavaScript and Dino. So let's go ahead and run this server file. For that, I'm going to write Dino run server.ts. And I had a feeling that it is going to compile successfully, but there will be a permission denied because we haven't really allowed this particular file to access the network. And it is actually asking us to explicitly define this allow net flag so this can actually work. So how about we go ahead and do that? Allow net. And it doesn't work like that. You have to actually define allow net right after run. For example, not here, but actually right after here. Allow net. And now when I run this, you can see the server is actually running on localhost 8000. And there you go. This is what the server looks like. It's printing out hello Dino. We can actually kind of go ahead and go crazy here and change something here. Hello Dino, you are crazy. So it's not working because it's actually using a compiled copy from here. I'm going to actually recompile it. And now if I go here, it's recompiled. So these are a couple of examples to, kind of get you started with Dino. For more, I would recommend you to go to dino.lan and check out the manual. It has all the documentation and everything inside it, all the tools that come along with, Dino, the bundler, debugger, dependency inspector, document generator, which sounds really, amazing. And the default formatter, the test runner. And there is also going to be a Dino linter, which is sort of coming soon. I believe all of these tools are going to be very, very helpful for you to write modern TypeScript or modern JavaScript. And it is actually going to really help Dino kind of succeed because it comes with all these, built-in tools, a standard library, a standard formatter, a standard, testing and benchmarking tools, a linter, hopefully in the near future. Like you don't really have to even configure TypeScript to be able to run this kind of thing. And if you are just starting out, I would recommend you to go to begin.com. It is sort of a modern, website, modern app hosting that actually supports, you can go ahead and sign up for begin.com, connect your GitHub account. And when you have connected your GitHub account, you can create a new app. And from the examples here, I'm going to be using, let's say, a hello world example from the Dino example apps that is kind of given in the begin.com dashboard. And I'm going to call it begin hello world API app. Let's go ahead and create it. So begin.com is kind of setting up the application environment for us, the production staging, and it sort of is already done. If I go to this particular GitHub repository that it has generated for me, I can go ahead and see what the source code looks like. So there are a couple of, dot files that go along with this particular repository. But the most interesting part is inside source http get index folder, where we are going to take a look at index.ts. It is actually generating a simple string, which is our HTML. And then it is returning this as a text HTML in character set UTF-8. It has the cache control, and all of this is stored in a body variable. And this body is being returned here as soon as the request is received. So let's go ahead and try it out. For example, here's a production URL for this app. So here you go. This looks really nice. For let's say if I edit and change something here. Hello world, Dino is crazy, awesome. And then just commit that particular change. Begin is going to probably start setting things up again. I think it has already applied my recent change. If I just need to go ahead and refresh, I think something went wrong here. Hello world, begin app is ready, and whatnot. I needed to deploy it to production. and ship it. And it looks like it is shipped. The build is right now working. And there we have it. Let me just refresh it. Hello world, Dino is crazy. This is amazing. I think we can just go ahead and remove this part just to see if it is now working. There you go, your Dino app is ready. And this time I'm going to be writing a better commit message with emoji log. So new index, just for the sake of fun. So I have committed this new thing. It is now building in the staging. And there you go, the staging is ready. We can just go ahead and deploy it to production. Go ahead and ship it. And it's shipped. We can just go ahead and refresh it. And there you go. Hello world. Dino is crazy awesome. So this is pretty much about it. I have actually shown you 3 different applications that you can build with Dino. You can use begin.com to start building and deploying Dino apps, and use dino.land to kind of go through the entire documentation, look at all of these third-party modules that kind of already exist, because Dino has been in kind of this development stage for about, I think, 2 years. And the 1.0 has just landed. The 1.0 is kind of stable now. And Dino is created by Ryan Dahl and other contributors. Ryan Dahl is the same person who was behind Node.js early on. And I recommend that you go ahead and read all of this Dino 1.0 blog post at dino.land/v1. It kind of portrays the image of where and why Dino came into being. Watch this design mistakes in Node.js presentation by Ryan, and then kind of take a look at what promises are being made, how Dino is going to support all the standard APIs inside your web browser, so you can actually compare both this command line tool to this command line JavaScript runtime to an actual V8 engine, and all of the promises that are being made, how they're using the REST API, the stability of this particular version, the limitation it has. And there are other things like the performance benchmark, which kind of shows that right now a Hello World Dino HTTP server is actually slower than a Node.js program, which can get like 34K requests per second, whereas Dino can get 25K requests per second. But there are more things that they are doing here. There's the TSC bottleneck, and there's an entire plugin ecosystem. If you go to the menu, there's the standard library that you can take a look at. It has a lot of things inside it. For example, bytes, colors, flags, formatter, hash, and whatnot. I recommend that you go to all of these and kind of try these out. And then there are the third-party modules. For example, one I could think of is, for example, let's imagine this one, the bump. For example, if you add a project.json file, which I think is going to become sort of a default in the Dino land, it can actually help you, bump this version inside of project.json. It's a third-party module, and it's sort of a GitHub repository that is linked here. And that is pretty much about it. Have fun building Dino applications, and definitely let me know what are your thoughts about the Dino versus Node.js argument, and let's see how Dino evolves. I hope it is better for the entire JavaScript ecosystem, the entire dynamic programming languages ecosystem, since JavaScript is like the most common dynamic language. I hope it turns out really well for the entire web and JavaScript community. Bye. See ya.